Hi dears, welcome to my channel. Today we are learning class 10 third lesson metals and non-metals. What was the second lesson? Acids, bases and salts. There I have asked you 3 questions. Do you remember? It's the time to answer these questions. Calcium phosphate is present in tooth enamel. Its nature is dash was the question. First question, the answer is basic in nature. Okay dears. Second question was dash is used for making glass and soap. Sodium carbonate is the one which is used for making glass and soap. The sour taste of curd is due to dash as it was the third question. The answer is lactic acid. Now we are moving for the third lesson. Metals and non-metals. As I am saying earlier itself, it is not that much big lesson. It's a small lesson. First, let us see what are the things which we have to go through the lesson so that it will be easy for you to learn. Okay. First, we have to go to the physical properties of metals and non-metals. Physical properties. That means luster property, hard nature, all these physical things. No, so these physical properties we are going through. These things are the physical properties of metals. Whether it is good, it is doing for metals, and whether it is going for non-metals, we are going to see. Then we are going to see the chemical properties of the metals. What are the reaction of metal with water? What is the reaction of metal with oxygen? What is the reaction of metal with another metal? Like that we will go and see. Then what we have to go? We have to go through the metals. How the metal is reacts with a metal salt. Other metal, how whether it will displace or not. There we are going to see the reactivity series. Then we will discuss how the metal is reacting with a non-metal, that is ionic nature, how the ionic nature is formed to the metal and how it is reacting with a non-metal, and what are the particularities or what are the specialities of the ionic compounds formed by that way. Then we will go how the metal is occurred, how we are able to extract this metal. Based on the reactivity, we are dividing it into 3. How we are dividing it into 3 and how they are reacting, all this we are going to see. At the end, we are seeing whether corrosion is happening in metals and how we can prevent this corrosion. If we are touching all these parts, that means the lesson is completed. Okay? That much only. Don't take it in a serious way. So I will help you to learn the lesson. Dears, first as I told you about the physical properties. Physical properties between metals and non-metals. Here in the textbook is not there whether as a comparison, but for making us study easily, I am doing it in this way so that easy for us to learn. First, luster property. As you have seen it in the first chapter itself. Many things are there from the first chapter itself. We are learning again here. It is luster property means shining appearance. Shining appearance is there in metals or non-metals. Shining appearance can be seen in metals. No? The non-metals, for the non-metal you can take an example of wood. It is made of carbon, right? So the wood is taken and here you can take any iron or gold even. Gold, you are taking the metal. Take something in mind as gold as a metal and wood as the non, or coal, coke. You have learned in 8th standard, no, coke or coal. It is made of carbon only. That much black it will be. So consider non-metal. For the non-metal you are considering that, and for the metal you are considering this. Okay. So will the gold shine, dears? Yes. So shining property is there in metals. And for non-metals, is there any shining property? Will the wood be shine? No. It is not having shining property. Hard. Whether the metal is hard in nature? Yes, the metal is harder. But all the metals are not harder, dears. There are some exceptions. For example, sodium, lithium, potassium, they are much more softer. Even with a knife we can cut it. Okay. So there are exceptions. For that, after this whole class, there will be some videos. You will get some videos from me which gives you the information of the important points of the lesson by in the way of questions. And moreover, we will discuss previous question paper also. What all the things has been asked in the previous question paper from this lesson. That also we will discuss. And questions, here which question will be coming. Because all these things, if I am moving in this lesson, the lesson will be much more bigger and it will be difficult for you to understand also. So now I am going through the lesson. After that, small videos I will put for you for making the lesson easy in your hand. Okay, in the form of questions, I will give you. Okay, dears? All the metals are not hard. Sodium, potassium, all these things are a little softer. Okay. The non-metals, we can't say all are soft, but still we are saying compared to metals, the non-metals are softer. And the third one, state. The metals are accessed in solid state, except what, ma? Except what? Except mercury. Mercury is existing in the form of liquid, right? What about the non-metals? Non-metals, oxygen, hydrogen, here, all these are what, ma? They are existing as gas. But as we know, carbon, all these things are existing. Carbon is existing in solid. We can't say that all are gas, but there are many things which are in the form of gas as well as in solid. So non-metals will be existing in the form of gas and solid. Okay, except what, ma? Except bromine. Bromine is existing in liquid form. Then in room temperature, whatever we are saying, we have to add on in room temperature, because as the temperature is varying, the state also will be changing. That also you know it. Then malleability. What is this malleability? We will be able to make it in a form of a thin sheet. Is it possible for metals or non-metals? It's possible for the metals more. For example, gold in the thin sheet it will be available. No, thin. You may have learned how that by 11th standard you will learn. The gold has been made into thin sheet of point not 0.003 millimeter. To that extent, the gold has been made into thin sheet for the bouncing of atoms and all. Okay, you will learn in the 11th standard. It is for that I am saying that malleability is more. That is, making into thin sheet is more. In which case, no metals, and it is not possible for metals. Then ductility in the form of wire. Is it possible for the metals to draw in the form of wire? Yes. A best example is copper, silver, because they are able to be made in the form of thin wire. If you are cutting the electric wire, you can see some small thin lines. No, it is actually copper wire. Okay, it is possible for metals and it is not possible for non-metals. Then the next is conductivity. What is this conductivity? Whether it is able to conduct heat as well as electricity. Metals are the best conductors while non-metals are the poor conductors of electricity. Then about the density. Density means, density you know, no? Metals are having much more density compared to non-metals. Then sonorous property. Is it possible for us to make sound when we are touching in a metal? Yes. In the school, when the bell rings, you will run away, right? Now it is not there, right? But still, in some schools, it is prevailing now also. It will be in the form of dosha tawa. That much round it will be, and with a hammer like thing, they will mang, 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 mang. It is made of metal because sound is coming only for metals. Okay, for not only that, guitar, all these veena, all these strings are made of what, ma? Is it made of wood? No, the strings are made of metal. So that when we are just touching it, what will happen? The sound will be coming. Which also is coming ductility, because metal is ductile, that's why it is able to be in the form of thin wire. Moreover, the sound is coming because of this. So two things are satisfied over here, right? Ductility as well as sonorous property. Then the last word, there is no space for me, so I didn't write. Actually, what will happen when metal react with oxide, oxygen? Metal form basic oxide, while non-metal form acidic oxide. So the physical properties between the metal and non-metal is finished. Now we are moving for the chemical properties. Dears, now we are moving to see the chemical properties of the metal. That means how the metal is reacting with oxygen, water, then how it is reacting with some acids, bases, all these we will see. Okay. First, chemical property here, how the metal is reacting with oxygen. When metal is reacting with oxygen, we will get metal oxide. For example, aluminium. Aluminium, when react with oxygen, aluminium, you know that it's a metal, right? When react with oxygen, we will get oxide of it, Al2O3. I think it is difficult for you to learn Al2O3. You have to learn by heart. From this class onwards, you are not learning anything in by heart. We are using what, ma? We are understanding how you have to learn. isn't it? So for that you should know where the aluminium is. Aluminium belongs to which group, ma? Boron family, isn't it? What is the mnemonic for that? Being alone gains intense toil naturally. Have you seen the last video, group video? I will put it in the description for you to go through it again. Okay, ma? Being alone gains intense toil. That is boron family, ma. See, boron, aluminium, gallium, indium, thallium, nihonium. That is being boron, aluminium, being alone gains gallium, intense indium, toil thallium, and naturally nihonium. In that manner, for everything I have made that this mnemonics, so that it will be easy for you to identify which belongs to which group, and it will be easy for you to writing in all these. Okay, so aluminium Al plus O2, how it comes Al2O3? You know, aluminium belongs to boron family, which is having +3 oxidation state. What is oxygen? In which group it is? Oxygen in Chalcogen group, ma. Oxygen is in Chalcogen group. That is, it is having -1, it is having a -2, like that it is moving. So oxygen is having what oxidation state? -2. So Al plus 3, ma. Al plus 3. Plus 3 oxidation state. Oxygen, ma. Oxygen can take 2 electrons, 2 minus or -2. So how many aluminium should be there for the oxygen to be compensated? That is, we can see we need some maths, ma. +3 into 2 what, ma? Is equal to 6. -2 into 3 what, ma? 6. So this is the aluminium, number of aluminium, and this is the number of oxygen. Otherwise it will not be 6. If +3 is multiplied by 3, what will we get? +9. If oxygen is multiplied by 3, we will get 6. The number should be proper. So when aluminium is multiplied into 2, we will get +6. So +6 electrons it can lose. While oxygen, when 3 oxygens are there, it can take 6 electrons. So Al2O3. That's why it is getting in this way. You need not learn anything. If you are knowing the group and what is the state, what is the oxidation state, or how much electron it can lose, or how much electron it can gain, it will be easy for you to understand the formula. Okay, dear, Al2O3. Then this Al2O3, when reacts with HCl, hydrochloric acid, what will happen? What will happen? As we know, chlorine is having tendency to gain how many electrons, ma? 1 electron. Aluminium is having the tendency to lose how many electrons, ma? 3. That's why, aluminium is having the tendency to lose 3 electrons because it belongs to boron family, +3 oxidation state. And the chlorine belongs to halogen family, -1 oxidation state. -1 is the state. So it is having the tendency to lose. So how many aluminium should be added to chlorine? For 1 aluminium, 3 electrons it can lose. So 1 chlorine here, second chlorine over here, and third chlorine over here. So how many chlorine should be there? 3 chlorine for 1 aluminium. Did you get, ma? That's why AlCl3. Don't learn it by heart. Understand and learn. So the things will be very easy for you. So AlCl3 plus H2O. Did you get, ma? Like that, when aluminium reacts with sodium hydroxide. So here aluminium oxide Al2O3 is reacting with, that means metal oxide, when react with hydrochloric acid or any acid, we will get salt. When in the same time metal oxide, when react with sodium hydroxide, what is sodium hydroxide? It's a base. So what will we get? NaAlO2. NaAlO2 means sodium and aluminium, along with that oxygen is there. So aluminium is having it's able to lose how many electrons? 3. Sodium is in which series, ma? Sodium. Halina, those who have seen it have understand this. Halina keeps rubbing costly frame. Halina, na means sodium. How much electron it can lose? 1 electron. So 3 plus 1, how many electrons, ma? 4 electrons. Here oxygen is added. Oxygen, how many electrons? 1 atom of oxygen can gain 2 electrons. So 4 electrons are there. Sodium giving 1 electron, aluminium giving 3 electrons. So when one oxygen is coming, 2 electrons will be bonded. When another one oxygen is coming, other 2 electrons will be bonded. So how many oxygens are needed? 2. Now is it clear for you? So NaAlO2 plus H2O. In this form, the reaction will be. Okay. Sodium oxide Na2O plus water gives NaOH. So it becomes metal oxides. When reacts with water, what will we get? We will get alkali, NaOH. Okay. Now the second thing is metal when reacted with water. When metal will reacted with water, we will get metal oxide again plus hydrogen. Metal when reacted with water, we will get what? Metal oxide plus hydrogen. K plus OH. K is having which oxidation state or how many electrons it can lose? Halina keeps rubbing costly frame, isn't it, ma? So K keeps which how many electron it can lose? 1 electron. Halina keeps rubbing costly frame. K, so it can lose 1 electron. OH minus is having negative charge, minus 1 charge. So directly combination, giving, taking, only one, here only one. So KOH, easily, isn't it? And when metal reacts with acid, we will get salt as well as hydrogen gas. The gas will be evolved. When metal reacts with acid, what will we get? We will get salt as well as hydrogen gas. There are many exceptions which they are saying in the textbook. We will go through it while we are discussing the questions, so that various types of questions you can expect, and I will ask you in that manner, and the explanation also I will explain to you. By the time it will be easy for you to understand. Okay, dears? We are going to see the reactivity of metals with metal. Now we are seeing how the metal is displacing other metal salts. Will all the metal displace other metal salts? See, we have studied in first lesson. Do you remember? When iron nail is dipped in copper sulfate solution, after sometimes the color of the copper sulfate solution will be changed and the iron will be changing. There is a brown tinge on the iron nail. Do you remember, dears? It was called a reaction. What was its name? It was displacement reaction. Do you remember? Iron nail when immersed in copper sulfate solution, after 20 minutes, it becomes brownish and the copper sulfate solution is changing its color into blue. Because copper sulfate solution is having the color green, the color will be changing into blue. This is a kind of displacement reaction. What is happening over there? Iron displaces copper from its solution and it is sitting in its place. So, it will be changed into iron sulfate solution for its sulfate solution plus copper. That's the reaction. So, will all the metal displace other metal? We can't say that. There, I have told you there is a series called reactivity series. Based on that, it is displacing. And there also we have given an introduction to it, and mnemonics also have been seen. See here, reactivity series. Do you remember, dears? According to the reactivity series, the most reactive one is potassium. Then it is going like this: potassium, sodium, calcium, magnesium, aluminium, carbon. Carbon is a non-metal, but still it is added to it, so that we will come to know in which place the carbon will be for that. Okay, dears? Then zinc, iron, tin, lead, hydrogen, copper, silver, gold. If mercury we are adding, we will add on in between copper and silver. This is the series. And here for that I have made a mnemonics. It will be easy for you. Pavitra starts calling Meena after coming zoo in time, leaving her costly silver gold at home. Instead of that, we can add on mercury also. So leaving her costly marble silver gold at home. Okay, this we can change this according to our wish, but the things will be easy. So again, I am telling you, it will be easy for you to learn the mnemonics. But if you are learning only mnemonics and not this series, it will be difficult. Of no use, da. For helping you, I am giving you mnemonics. It doesn't mean that if you are learning, Pavitra start calling Meena after coming school. Like that, if you are learning, but if you have not learned what it is, it will be of no use. Okay, ma? Here again, I am saying potassium. We are taking it as P, not as K, ma. P means it is not phosphorus, it is potassium. For our convenience, we are taking potassium. We are not taking the symbol of it for doing the mnemonics. So that it will be easy for you to understand. Pavitra starts calling Meena after coming zoo in time, leaving her costly silver gold at home. So there is a sense or a meaning in it and easy for you to learn. Here potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold. So here where is copper ma? Copper is here, and where is iron? Iron is here. So this iron is much more higher compared to this copper, so that it can able to displace copper from the solution and it can sit in its place as copper iron sulfate. Did you get ma? If the copper, instead of that I am asking you ma, if we are keeping copper in iron sulfate solution after 10 times 10 minutes, will there any change? No, because it is less. It is in the least reactive group and it is not able to displace iron. So you should learn for what purpose we are learning. The things which are in the higher in the reactivity series can displace the lower one. But the lower are not able to displace the higher one from this reactivity series. Did you get ma? You have to learn it. Okay. Now we are moving for the reaction of metals and non-metals. How the metals are reacted with? Will the metal and non-metal combine? Yes, it will combine. For what purpose they are combining? We will come to know. See, metals, what is the specialty of metals? Metals are donors. Isn't it? Karna, Veera Karna, donor. He is not I am connecting Mahabharata for our convenience, I am saying like that, okay? So, they, whatever it is they are leaving, why they are leaving electrons? Why they are leaving electrons? Because every element is having the tendency to attain noble gas configuration. Noble gas configuration. When we are reaching the noble gas, we will be stable. Stable configuration. No need of. If you are getting full marks on chemistry, is there anything for you? Anything more you want? No. What is your aim to attain the full mark? Isn't it? Like that, the noble gas is having all the things. To see, helium, outermost electron shell is having 2 electrons. It is stable. Then neon. It is 10. It is having 10. So what is atomic number is 10. What do you mean by that? 2 plus 8. First shell 2 electrons, second shell 8 electron. It is sitting stably. Like our saint. No need of any wishes to get this, to get that. Nothing is there. But so here see ma sodium. Sodium is having plus 1 oxidation. Now why is it so? Neon got 2 and 8, it is stable. Then comes sodium. Sodium is having only 1 electron in its outermost electron. Why this electron is coming? I don't like you, like that the sodium is saying, and it is having the tendency to pull that electron away, so that it will be what? It will be having stable. That's why all the metals will be having tendency to lose. Okay. If we are coming near to the noble gas, what will happen? We are saying it as non-metals. Non-metals want some electron. Somehow, if I am getting some electron, I will be able to attain the noble gas. Did you get ma? To save oxygen. Oxygen, when if it is getting, oxygen is having first shell 2 electrons. Second shell, total it is 8 electrons in its shell. So, first shell will be having 2 electrons. Second shell will be having 8 minus 2 is 6. So 6 electrons. It needs 2 more electrons to attain what ma? To attain a neon. To get stable configuration, it needs 2 electrons. So whoever is giving, I am going to purchase. It is like beggars. Please give me. Please give me. Metals are what ma? Donors. And these are, don't say to your chemistry ma'am. Okay ma? It should be secret within us. Okay, so this oxygen, 2 electrons it is asking for 2 electrons. So, or this fully ma. So, this full will ask ma 2 electrons. This full, fluorine, chlorine, bromine, iodine, astatine. This full will be changed. What is the mnemonics? Do you know? Failed class brought into astonishing tsunami. Do you remember? It will be easy for you. Mnemonics, if you are learning mnemonics only, of no use ma. If you are learning this thing and if you are learning mnemonics also, at the exam time, quickly the bulb will glow. That's why I am saying. So fluorine, this, it needs only 1 electron to attain it. So it will ask for 1 electron. Here, No need of extra electrons, so it is giving. Okay. What about this beryllium family? Beryllium, magnesium, calcium. Betty's mug carries strawberry, blueberry, strawberry, banana, raspberry, isn't it? Okay. In this mnemonics, what is this? Beryllium family. It is having the tendency to lose 2 electron. 2 electron if it is giving, so magnesium, see, 2 electrons extra. Here 1 electron extra, here 2 electron extra. If it is giving 2 electron, what will happen? It will attain the this noble gas configuration. That's why metal gives 2 electron or 1 or electron, whatever it is, the electrons they are having, and the non-metal catch these electrons which they are giving. For what, ma? For making themselves stable. This is what? This is how the ionic bond is formed. By this way, what will happen? Ionic bond is formed. Can we go quickly on it? See, sodium. Okay. I have left chalk, everything down. See, sodium is having extra 1 electron. Okay. So for that I am writing for a convenience. Na gives Na plus 1 electron. Losses, I don't want you. I am leaving. Like that it is giving Na plus. So Na plus it is now. Okay. Then Cl is coming. Cl want what? Cl is taking this electron. Cl plus 1 electron gives what, ma? Cl minus. So it gains 1 electron. Half. Now I got 1 electron. So it is there. Then what? Na plus Cl minus gives what, ma? NaCl. What is that? Our common salt. In this form it is. We are discussing ionic compounds, right? So 1 atom of sodium and 1 atom of chlorine will form NaCl because sodium leaves 1 electron and chlorine takes 1 electron. In the case of magnesium, what will happen, dears? Magnesium is in what, ma? Magnesium is having the tendency to give 2 electrons and the chlorine has the tendency to accept 1 electron. So magnesium will combine with how many atoms of chlorine? Magnesium, 1 magnesium, 2 electron each. Here 1 electron, 1 chlorine, here 1 chlorine. So MgCl2. Like that the compounds are formed. This is about the ionic bond compounds. Now we are going to see the properties of ionic compounds. They are having high melting point, high boiling point because they are much more stable. So much more energy have to be applied to break it down. Okay, that's why they are having high melting as well as boiling point, and they will be having. They are soluble in water. Most of them are soluble in water. For example, our sodium chloride. Salt is soluble in water, right? So there are much more the ionic compounds which are soluble in water, but they are not soluble in kerosene. Then what about, is there any soluble conductivity? They will conduct electricity in molten stage. In the molten stage, they will conduct electricity. Now we are moving to see the big thing, that is how the metal is occurrence and how we can able to extract the metal as itself. Okay, dears. See, there also the reactivity series will work. See, Gana, they are highly here. They are what are they? They are potassium, sodium, calcium, magnesium. All these are up to aluminum. They are highly reactive. So, can that metal exist as such, or will be it exist in some other form? They will be existing in some other form because they are not able to exist as idle, because they will be always joined with some other non-metals, or they may be joined with some other oxides, and some they will form oxides, sulfides, carbonates, or in some other form. For example, these things will be present in the form of ionic compounds much more. So they can be separated by the means of electrolysis. See here, metals with highly reactivity, when they are reactively more, that is potassium, sodium, calcium, magnesium, all this coming in this category, they will be in the form of molten ionic bonds. For example, sodium chloride. Sodium chloride is much more, no? So these things will be in the form of molten compound, the compounds between the molten form. Then we are doing this electrolysis. Thus we will get the pure metal. The electrolysis means we are passing electricity through the molten compound. Then NaCl. If NaCl is the Na plus and Cl minus. So sodium Na plus in the form of Na plus we are getting like that. The metals which are medium reactivity, they are having medium reactivity. For example, zinc, iron, tin, All these are medium. They will react, but they will be having medium reactivity. But they are not existing as the metal itself because the reactivity is there. So they will be existing in the form of carbonates or sulfide. They will be existing in the form of carbonate or sulfide. So by calcination or by roasting, we are able to take it in the form of oxides. We are removing it in the form of oxides of the metal. Then we have to reduce this oxide so that we will get the metal. Then we have to go for purification. For example, here I have given you zinc. Zinc, Anna. Here zinc it is. Zinc. So this zinc in the form of zinc carbonate. So what they are doing is we are applying heat over there. So what will happen? Zinc will be reduced in the it will be changed into zinc oxide. It will get oxidized. Zinc oxide plus carbon dioxide. This zinc oxide, when we are applying carbon on it, what will we get? Zinc will be in the form. Zinc will be obtained in the pure form, and oxygen will be along with carbon. Okay, by this way we can take it out. Then low reactive. For example, low reactivity we can say mercury. Mercury, I told you, if we are seeing mercury will be in between copper as well as silver. So mercury is less reactive compared to these things. So how it will be occurring? It will be occurring in the form of sulfide ore. Mercury in the form of sulfide ore. When we are roasting it, we will get the metal. When we are getting the metal, we have to refine it for getting the pure metal. See, mercury sulfide Gs plus oxygen. When we are applying oxygen, we will get mercuric oxide. Then when we are again applying heat, we will get mercury as well as oxygen. In this way, we are able to get. We are seeing how we are extracting the metal, isn't it? Those which are highly reactive can be accessed in any state, in any form. That means it can be accessed in the form of carbonates, as sulfides, or in the form of oxides, or in as ionic compounds. That's why in molten state electrolysis is the way which is the best way for it to get extracted. Just lower than the highly reactive, we are converting, it will be existing in carbonate form or in sulfide form. We are extracting it. Okay, we have seen it. Then below it will exist maximum in sulfide form. For example, we have seen that mercury. Okay, like that. When they are much more below, least reactive, means what? The metals will not react. They don't like to react. They will be existing as such. For example, gold. Silver also silver sulfide is existing. But for gold will be obtained naturally from the soil itself. So what we have to do, if we are taking the gold, will not be that much shiny as you are expecting. So we have to refine it. Refining is the process which we are doing for the gold. Only that process we are doing. What is it? It's just like electron, very much more shiny also. Okay. In this form, refining is a process which we are doing for now. So based on the reactivity, what we are finding, how we are able to extract the metal, we have seen. Now we are going to see corrosion. What is corrosion? The surface of the metal will be changing its color because of the reactivity with the surroundings. That is called corrosion. Okay? For example, iron. Iron, if we are keeping it for a long time, what will happen? Rust will happen. Isn't it? Rust will be there because it will be changing from its color to what? Some brownish tinge will be seen. For example, your some another example is your anklets, silver anklets. Okay, when silver anklets, when we are using for the first time, it will be much more fresh, good. It will be much more shiny silver. But after 4 or 5 months, the color will be changed, right? It will be black. A coating of black color will be seen in your anklets. Okay, isn't it? Have you not seen? Okay, it will be as black in color. Means silver will be coated with sulfide, so it has become the outside part or the outer layer will be changed to black color. Silver sulfide will be formed. Not only that, for copper vessels, after some days, if you are not washing it properly, what will happen? A green color will be formed on the outer layer. It doesn't mean that algae had come. It is not because of the algae. Don't go to biology. It's chemistry only. Means some carbon dioxide. Carbon dioxide, it will react with this copper and forming the green layer of it. So It means that part of the copper or silver or whatever it is will be reacted and is going away. It should not happen, right? Will you allow for that? No. So we have to prevent it. How we can prevent it? For example, when we are taking a gate as an example, we are painting the gate, no? With your favorite color, you are painting it. Some houses gate will be yellow in color. Some will be those the children like pink. The gate will be pink in color. For what purpose gate is painted? Not for, not only for getting beauty, but also a reason behind it. So that what it is, the iron items will be coated with the paint so that it will not touch to the surrounding air and will not be corroded. For that purpose, painting is doing. Okay. Normally, for the iron articles, we will do this galvanization, that is coating of the iron article with the zinc, a single layer of zinc, so that it will be coated with zinc. So for the zinc, there is no effect will be caused like iron. So the moisture will not be touched in it, and the iron articles will be as pure. Okay, dears. These are the methods which we are using for preventing this corrosion. Moreover, alloys. Do you know alloys? What are alloys? When a metal, when we are mixing the metal with some other metals or some other non-metals in a fixed proportion, we will get alloy. We will be having the characteristic entirely different from the metal which we are expecting. For example, iron. Iron is actually iron is very soft, but when we are mixing 0.05% of carbon, it will become so hard. Okay, so carbon is a non-metal. When we are mixing with iron, what will happen? It will be so brittle, so hard. Its properties will be changed, and it will be useful for you to use. Okay, for this dumbbell, all these we are using because it's so hard, right? Okay, then is there anything more to say? Yes, as I told you, there is one more alloy for mercury, that is amalgam. Amalgam. It may ask for you. Now after this class, I will keep some videos for you which will be related to the questions and answers or fill in the blanks or previous question papers. All these will be added to that so that the lesson will be much more clear for you, because you are 10th standard, isn't it? Everyone's eyes are on you, what about the marks. So I thought to help you by the way which I can. Okay, dears, you have to learn something. So brass, what is the alloy? It is made of what? Copper and zinc. Brass, then bronze, copper and tin, like that. These alloys, all these you have to learn. Okay, it will help you. Now we are finishing the lesson. Okay, so it's the question time. It's our question time. Shall we start the questions? Okay, first question. Dash is the hardest substance made of carbon. Which is the hardest substance which is made of carbon. Second one. Dash is the best conductor of electricity. Dash is the best conductor of electricity. Which metal it is the best conductor of electricity? Okay. Third one. Name a non-metal having lustrous property. Luster property is showing by, I told you that all the metals show luster property, but a non-metal is also there which shows the luster property. In the textbook everything is there, just read the textbook, the things will be there. Bye.